Welcome to the February 21st overview of Everywhere Computer. My name is Boris Mann. I'm the founder and CEO of Fission. We've got lots of other members of the Fission team on the call today who are all building this together, including my co-founder and CTO, Brooklyn Zelenka. And let's get started. The Everywhere Computer is the name of the platform that is the primary product that Fission is working on right now. We have a history of building protocol first. So what that means is we work with different ecosystems, doing research and solving hard problems in distributed systems and cryptography in order to put an entire edge stack together to make it easier and more portable for developers to build applications and for end users to have a private and secure experience in apps that they use, all with an open source stack. So we started with UCAN, which is our decentralized authentication method. We used that to build WinFS, an encrypted file system, a little bit like Apple's iCloud. And then finally, IPVM, which is compute. Identity, data, and compute is what we've been working on to put together as sort of low-level pieces. And we're now putting this all together in the Everywhere Computer. So what the Everywhere Computer is, it's a network of functions and computation with payment included. So you can run your own instance, or you can rent it from the network. You can write functions in Rust, JavaScript, and other languages over time. And you can also include any authorized service with that. Because we're building this on top of these protocols, it means that much like Amazon, having a giant directory of web services, as well as Google Cloud and Microsoft's Azure, once you're in those networks, and you have an account on there, you have a tendency to keep using all of the services that they provide. And it's a barrier to use a service that isn't from those big cloud providers. And that's what we set out to do, is to have a way to be able to include any open web function and kind of run it everywhere, hence the name. So another look at what all the pieces are around this is our branded network platform. When I say branded, all of the components that we build are open source, so different people can use them and compose them and make different types of applications and services. It's been great to see people adopt the stuff that we're building. There's the folks from Fileverse, Subconscious Newsphere, the Web3 storage folks, some of the early usages over at Blue Sky, and we're just talking to them yesterday that were inspired by or directly used some of the protocols that we've worked on. We're taking all of these and putting this into the Everywhere Computer platform. So this is, hi there, welcome. I'll pause for a second as some folks join us here. As I was saying, please feel free to either use chat or unmute yourself and say hi if you'd like to. So the pieces that we built so far is a control panel interface that we'll be adding accounts to. This will include a payment, networks, and billing, a curated function directory, managed compute providers, and third-party services that I kind of mentioned before, where you can plug in any sort of service. It doesn't have to just be a small function. That's kind of a lot, so I'll go over that a little more slowly and explain some of the other logos that we have going on here. So Fission will operate some compute ourselves. We will plug in third-party compute of various ways. So for example, we had a discussion with the Filecoin station network that have about 10,000 people running their station service on home desktops. So we're not intending to get a bunch of people to run that, but ideally those type of functions can be made everywhere computer compatible, and the functions can be run on that network. We'll also run a handful of compute ourselves and use large cloud providers that have commodity compute. And I've got a kind of label in there for enterprise compute. So we've had some early discussions with folks like Intel, who are interested in having some large corporate clients, possibly even use their fleet of desktop computers running everywhere, or obviously having their own data centers where they can then run functions on their own and mix and match that. So what Everywhere Computer will do is a kind of routing, or an Uber for compute, where we won't own all of the compute, but we'll route it to elsewhere in the network, either based on geography. So if a bunch of the data and the compute that's needed is in France, then it will be faster to run it in France compute if there are local nodes that want to do that, with low latency. But it might be very expensive. So you might want to optimize for, I don't care where it runs, make it really cheap. And so that might be wait over time for compute that happens just on home desktops that are happy to just earn a little bit for running some compute when their computer is idle. Fission will basically making this in a distributed fashion where you're tracking billing and cloud function usage is much harder than just a centralized system. We'll do a mix of that with Everywhere Computer. I have the Stripe logo in there. So the simple mode where you'll be able to come to Everywhere Computer and in your account, attach a credit card and pay for that. Because our design goal is for literally everyone to use this, one of the barriers with, in fact, a credit card system is that, especially in emerging markets, I'm talking really large ones like Brazil, India. I was just in Turkey and met a young man there who is in fact running his web app from his laptop at home. Why? Well, one reason is that he's got a 1 gigabit home connection, so it means you can run stuff from home today. And two, he doesn't have a credit card, so he can't use a lot of the things that modern web developers might be using in systems today. So we'll also support a credit system where basically if you run your home computer and perform useful work for the network, we'll hand you credits that you can then use to ask the network to run your functions when you're not online or your home network connection is down and other things like that. I've also got some new diagrams on here of the Optimism network, the Ethereum mainnet, and the Coinbase base network. So we do see Web3 networks. Hey, Joshua. Did you have something?
Hey, sorry, I was unmuted.
No worries. No worries. So what we really see is a lot of Web3 networks are also interested in running functions at the edge. And so another way of doing payment would be, in fact, with those on-chain currencies. So the network would be doing work, and then there would be a settlement, and that settle could either be on Stripe or one of a number of different networks that says, yes, I want to pay for useful work that is being done. I have a little screenshot there of our current control panel that does a few little functions that we have in there right now. Over time, that will look like, if you're familiar with NPM, the JavaScript registry, or even things like GitHub repos, that will be, or Docker image registries. This will be a registry of lots of functions that people can use without writing them from scratch. That's our other core insight as we've talked to various people writing compute. Running compute is that what they need is more functions and more apps. And we believe that much like we talked about giving credits for running things at home, we think that credits for people who write useful functions that get used in the network is another way to incentivize developers to write useful functions. because the very best code is code that you don't have to write. Asterisks, assuming it is useful and well run, and we think the sort of marketplace effect of people running efficient functions and developers getting paid for it will mean that there will be useful functions in the network over time. Okay, subnets. We kind of get progressively a little bit more complex in viewing what we've got going on here. A lot of this is going to be not one big network for a variety of reasons. One is stuff will run when it's offline and then come back online. It will be around the world, as I talked about. And that really means that you're already not going to be connected to all of the other things in the network. One of the things that we're exploring is this concept of subnets. So HomeStar is the name of the current engine that you run on your desktop. And you can imagine running a set of computers on a subnet with your team, an enterprise, a certain set of functions that are really useful for a certain domain, a company, those sorts of things. We will have a persistent cloud that we run with Everywhere Computer. And we are working towards having a beta subnet, which we don't have a better, cooler name yet for. But essentially, that will be the default setting, much like we have the instructions today, where you get set up and run. What I've also put on there and introducing is that we do use IPFS and content addressing for everything. And the demo will explain this a little bit. So by default, our beta subnet will be well connected with the IPFS mainnet. So any data that's on IPFS will be able to be read from the Everywhere Computer beta subnet. We'll make sure that functions that are published on the beta subnet are available and well reachable in the IPFS mainnet, and lots of both commercial and home providers of IPFS, like Pinata or Firebase or Web3 storage that persist things, should now be able to offer compute from the Everywhere Computer to people who have large IPFS data sets already. Quick news on the 0.2.0 release. Updated docs. Thank you very much, Brian, for getting that done today. And HomeStar is, again, the engine that runs the Everywhere Computer that's written in Rust for performance and portability. And what I'm going to do now is, well, I'll pause for a second, and then I'm going to switch over to a quick demo. Anyone else? Anyone have questions, comments right now? Hello, Doug. Okay. I'm going to switch over. Doug was one of the people at our unveiling back in November, so he can see what's the same and what's different.
Hello, Boris. I'm not sure if you can hear me or not.
Absolutely. Great to hear you.
So, yeah, I was scrambling for the unmute button, and I found it. Thanks,
Good.
Peter.
I need to try one more thing here. So. Thought I had everything up and running, but I've got one more thing here to do in the background.
Doug, you have recovered from the dense jargon that I was spilling in the secure design working group call.
Always good times. Always good times.
Okay, can you guys see the rotating EC logo on your screen right now?
It's a wonderful GIF.
Amazing. So what I'm also going to paste into the chat here is this is our getting started for setting up your local node. I have done these steps already. So what you see here is if you look at the URL bar here, we're actually at our hosted web page. I don't have any red dots on here, which means that I'm successfully connected. Actually, an interesting note, well, we have a red dot when we're not connected. Product notes. Ryan and Andy, we may actually want to put a "you are connected" note here locally. So while this is running as a regular web page, technically published to IPFS by Fission's infrastructure, it's connected locally to the thing that I have running. I don't have any red errors in here, and that lets me know that it's working. I'm going to do a quick workflow. I will do the most dangerous one first. What did I have here before? I have to actually be careful because I've done this multiple times, and because our system caches things. Let's do this one. This might be very slow. So what you're seeing here is I have a function called blur and I have a function called rotate. This is kind of a visual no-code builder that is mostly useful for demos, but it is actually generating a full workflow underneath. I upload an image, our reclining toucan, and I go ahead and hit run. That gets submitted. Hilarious. Okay, so I actually love this as a demo because it turns out I just use my regular image folders. And because I've already run this in the network, it says like, yeah, I ran this already. So that's one of the features of the Everywhere computer is when it's connected to a large network, or in this case, my local node, if I've run a computation before, it just skips it. And it shows me like, yeah, I already ran this. So
you can just click duplicate and change the sigma there, and you should get an uncached version.
Okay. So I will change. No, this is and then I hit edit, and I'll hit the sigma to 25. So different, and I will hit save and run. And now it'll take a little bit of time. Thank you, Andy. Run one, run two. And again, imagine a network where any of this stuff is done. Images are kind of obviously a good visual example. And this is the one where I'm like, oh, right, is it broken? Is it working? What even is going on? And it just turns out that blur is an expensive function. So it's now done success. It's rotated it. We've completed it. Yay, awesome, stuff works. So what we're going to do now is we're going to do it again with the same sigma 25. Sigma 25. But instead of a rotate, we're going to do a crop. Oops. No? Okay, well, we'll vaguely do it on screen there. Let's get our reclining toucan. So this is our same reclining toucan image. And so I have to hit save here. So I've created a new workflow here, workflow 8, and going in. And what we should expect here is that this blur should happen instantaneously because we just ran it, and then the crop will need to be run again. So let's go ahead and run. Boom. Conveniently, I cropped it so it's a transparent part of the image, which is why this is not a good example, but it shows things up and running. Amazing. That is the Everywhere computer up and running with some of the functions that we have as our test functions. We can see some activity over here, stuff that's running, recent activity, active connections, logs, and so on. So what I'm going to do now is I am going to run the Every CLI, but I'll switch back to the slides for this. Any questions or clarifications on what we just saw there? Awesome. What's your amendment?
Sorry, just a quick one, Boris, because I saw the second time you ran it, it reran the computations and it took a couple seconds, which gets me curious because I thought this was all supposed to be running in Rust and WASM and it's supposed to be blazingly fast. So is there a reason why? Like, is it compiling the WASM when you rerun it, or how's that working? Why is it a bit more lag than what we've come to expect from WebAssembly?
I can tell you really directly why. We tuned a blur function to be as slow as humanly possible for demo purposes. So
I love that answer. That's great.
yeah, so
WebAssembly
like,
is so fast, we needed to slow it down for you to see it.
yeah,
Okay.
like actually though, yeah.
Yeah, right on. Okay, I accept that answer. Thanks.
Yeah. There's a bunch of other things that we want to do with this, where ideally these sorts of things will be portable. So some of that might be run locally. You know, I have a powerful M1 MacBook Air. I don't need HomeStar to run it. I could run it literally in the browser. But if I want like 1,000 images and 1,000 blurs, that's the kind of thing that I would like parcel out to the network in different ways, right? So I think one of our challenges is explain to people, but what if you had functions that ran everywhere? And what if you didn't have to do 1,000 of them? Because it turns out if you just did one new one and the 999 were already done, amazing, that would be quite quick. And that's some of the advantages of content addressing the network. So the big thing that we ended up getting done in the last little while is the Every CLI. So thank you, Andy, Ugo, Ryan, and the rest of the team who worked on this. I was casually checking in if there was new stuff I could demo yesterday, and so you're going to see stuff that's like kind of fresh off the presses. We have a little unlinked page, but that link is live. With further links and GitHub and explanations and things like that. I'll drop it into the chat here as well. So what it does is it installs and boots up a local HomeStar node, runs a control panel interface locally instead of the hosted Fission one. So this will work offline as well, and exposes an API gateway to run functions on your own computer. So what that means is you've got your laptop open, you've got a control panel running, you have a HomeStar node running on your machine, and then you'll basically publish an API gateway out onto the public internet. It will tunnel to your computer, so you're literally running functions from your own machine. So this is great for rapid prototyping for developers. And over time, this lets us explore what this looks like to say, hey, I want an instant gateway. I want, when I close my laptop, for this to keep running. How can I do that? And that'll be some gateway services and other ways for you to both run yourself or rent from the network in different ways. So I'm going to switch over to my command line. Oh, yes. And I'll switch to the next thing here, is we are actually now supporting JavaScript functions. So you can, as Doug said, you can write very performant functions in Rust that get compiled down to WebAssembly that will run everywhere. There still aren't that many people writing Rust. And some of the other languages that are super popular are JavaScript and Python. And so what the team did is basically write source code in TypeScript. We use this componentized JS to transform it into WebAssembly, which uses an embedded SpiderMonkey JavaScript engine. So it's not as fast as Rust, as Zishan keeps reminding me, but it does unblock people who are comfortable in JavaScript to be able to write functions and deploy them. So we have a small selection of sample functions that's also on that link in the docs that I mentioned before. And over time, those will be published in the registry. So you'll even be able to create workflows just by browsing in that registry. Okay, demo gods, I'm going to run the Every CLI in the background. And I'm passing it a function, a very fancy add two numbers together function. And yes, this is an example of what's running. This basically has a local control panel. We'll start HomeStar. Oh yeah, I have a second HomeStar running. It gave me an error. HomeStar is not healthy. So I will, in fact, stop.
Boris,
So-
we're still on the slides. I'm not sure if you need to switch over your Zoom capture.
You're gonna see it. You're gonna see it when I have things up and running, rather than switching to the CLI, because CLIs are boring. Okay, processing function. Basically, I need to wait for the local web interface to come up. And so I'm basically passing it this add function. It's parsing it and compiling it. It boots up HomeStar in the background, but if you already have HomeStar running, it'll complain. So that's what I had to do. And then it'll run a local version of the control panel, which is just a web interface. And we've combined this all. It's all using the same code that we have running elsewhere, but it means that you can run it all offline and locally, which is the part that we've always talked about, and the sorts of scenarios where, if you're working on a plane, you should be able to use this without any external dependencies. The API gateway might work less well. Starting control panel. Woohoo! Okay. Now, what you should see is the control panel. This is going directly to just the add function. So we've written this in JavaScript. There's source code on disk. So imagine that you're typing away, writing some JavaScript, and you want to run it. And we're obviously it doesn't look very pretty, and we're auto-generating an add function. That will be extremely slow. Doug. This is slow because we're booting up an entire JavaScript function, JavaScript engine, SpiderMonkey in Rust. Woohoo, 11. So not very exciting. Showcasing that we can run things in JavaScript, and we will end up having these things computed over time. These are really very simple functions to showcase that it is up and running. We also have a local gateway interface. So that is the QR code. And here's the schema of the function endpoint, right? So we've taken a single function, made it into a little microservice that you can run. And here's the basically like interface for an add function. Brent asks, where is the compute taking place? Right now, I have just my local HomeStar node. We have all of the wiring in place for HomeStar nodes to talk to each other. And ideally, what the next thing that we're going to be doing is having a config for all of the computers all of the HomeStar nodes that you run to connect into the beta subnet. And then basically you would be connecting to a much larger network, much like IPFS is connected to a network of nodes. And the computation could be run anywhere in the network. Okay. Write in TypeScript. We have some small functions, API gateway. Write this in real time. Run functions on your own computer, exposed to the internet. So we'll have those docs up later this week. I know that Ugo bundled that directly into the Every CLI, where basically we've included it. And Ugo, I think you're using Cloudflare tunnels is what you ended up using.
Yes.
Great. Cloudflare has some
Well,
functionality. Go ahead.
We'll probably add we'll add a flag so you can turn it on, turn it off, the tunnel if you want. Right now it's like hard coded off, but we'll turn it into a flag in the CLI.
So Cloudflare has some functionality to be able to run some stuff on your local machine, and then it connects and routes it so that it's available on the open internet. That should work quite broadly, no matter like where you are and what kind of network you're on. Basically, the Cloudflare tunnels to your machine and connects it out. There's other methods like ngrok or tailscale, but for a developer experience, we really want it to be like, hey, follow this happy path. You don't have to worry about networking, and you literally will have functions running from your own machine. So part of that is actually a bit of a demo of exactly that. It is running on your machine. If you close your laptop and you have it written into an application, it'll be like the compute is offline. And the next step will be letting anyone in the network run your function and having a gateway that people can run. That is the main bulk of things. All of this stuff is up and documented at docs.everywhere.computer. We'll send out the slides to everyone attended afterwards. We've got a bit of a roadmap. Ryan and I are booking lots of product interviews. So if you're interested in tinkering or have an idea of how this will fit into compute at scale for you, we'd love to talk about your use cases. Ryan and I will both be in Denver next week for ETH Denver. So there's a bunch of things going on. We fit into a category of decentralized physical infrastructure, DPIN, as well as layer 3. So all of these are emerging terms in the Web3 space. And Fission has always worked at the edge and composed with all of these things. We've got a number of talks lined up already. We'll be meeting with some investors in town, talking about arrays for Everywhere Computer, and happy to meet in person, either yourself or if you've got colleagues traveling. I will leave it there and stop the slide share. Questions, comments, other things I can help answer for you about the Everywhere Computer. Doug, will you be in Denver next week?
I will not be in Denver next week. I thought about it, I planned about it, but no, it's not in the cards.
Yeah, I went back and forth. Ryan booked early, and then there ended up being a number of folks that were going to be in town that we'll have some discussion with. Where I'm also hosting with Adine an IPFS mainnet talk to talk about how we as a community run this large network.
So my question would be, so first of all, I'm sad that I'm not going to Denver now that I know that you're going to be there. But I mean, it's never too late to buy a plane ticket, right? So what's the time frame for running my functions on your computer and vice versa then?
Weeks.
Okay.
As I say out loud, and everyone's like,
Damn you.
We did this in person on the local area network already back in November. So it does, for those that don't know, Doug's involved with libp2p, and we use libp2p in HomeStar, and that's what it uses to connect peer-to-peer connections, working on the LAN. And the next part is basically this subnet mode is how we're going to do Bootstrap and other config settings. So ideally what we do is we hand you those config settings, and we do a bit of a star topology initially with like a hosted HomeStar to be able to run that. And we also hand that to other people to be able to run their own subnets. And then that should generally be available. And then we start to get testing live what it looks like to be gossiping workflows and receipts over a network.
Nice.
Yeah.
Nice.
Yeah, I'd say the other big thing is accounts. So without some permissions, and Brent asked some questions about security and permissions. With accounts in place, HomeStar already has some UCAN built into it. Everything in the system will have its own public-private key pair. And then you'll be able to like delegate permissions to different things. So things that we'll try is things like you might have a permissioned function. It's a fancy function, and you only want people that you trust to run it, or a permission compute node. So a Fission team subnet might be permissioned in such a way so only people on the Fission team can run computation on it. Or a little further down the line is things like quotas and accounting. So you have some capabilities that are based around how much compute you can run over time. Anything else I can help answer live? Awesome. I will hit the I can't even hit the stop record button because it's automatic. I can't hit the stop recording button because the way I'm set up right now. Thank you everyone for joining the demo and overview. Boris at fission.codes if you want to email me directly. Like I said, we'll send out a slide deck of all the things that we shared. Denver next week if you'd like to meet in person. What we're looking for is developers to write functions, people who are running compute at scale. This often looks like different companies or ecosystems. Last time we talked about using the Everywhere Computer for Farcaster frames. So our CLI and Gateway is actually going to be making a toolkit for running interactive Farcaster frames. So that's some of the other stuff that we'll document and make broadly available for everyone to use. Amazing. Thank you, everyone.
Thank you.